Good morning, good afternoon, and good evening, everyone. So today we're going to be continuing our calculus series, and I'm going to be talking about problem 4 of tangents to circles. Okay, so again, this is calculus 1. Let's jump right into it. So we have tools, right? I put them in purple. These are mathematical tools we could use to find solutions to problems, right? So let's do this. So draw the circle with the equation x squared plus y squared equals 25. So again, the equation of a circle, right? So that tells me x squared plus y squared equals 25. I can actually rewrite it like this. X minus 0 squared plus y minus 0 squared equals 5 squared. This tells me the center is the origin, which is 0, 0, and radius, which we'll just call r, is 5, right? We also know points on this circle. So let's quickly draw it, right? I don't want to be yapping too much. So again, how do we draw a circle, right? If we looked at my previous video, the way I do it is I find the middle or the center, and then I find 4 dots or 4 points, and then I connect them. So the first dot is going to be the center 0, 0, and that says my radius is 5. So my other points would be 5, 0. Oh, shoot, I messed that one up. I mean 0, 5. Maybe a 5, 0 here, a negative 5, 0 here, a 0, negative 5 here, and then I just draw. Or I kind of, oh God, that's not looking good. I guess I need more art stuff. Yeah, something like that. Yeah, looks alright. Yeah, oh yeah, yeah. There we go. So that's the circle. Now it says we have points -3, -4, and Q -8, 0. Now we ask, is P on the circle? What's the simplest way we could do if we want to find out if a point is on the circle? Of course, we plug it in, right? So again, x squared plus y squared is 25. We just plug it in. If I look at my P, I'm plugging in x as -3 and my y as -4. Is this 25? We'll find out. This is 9 plus 16. And oh my, it is 25. Yes, it is 25. So we say P is on the circle. Mind blowing, right? Okay, so P is on the circle because we plugged it in, the x and y coordinates of P on the circle equation, and we see that it does satisfy the circle equation. So we know P is on the circle. Okay, now that's the first question. The second question is the line through P and Q tangent to the circle? How do you know? We need to find the line through P and Q. What's the equation of that line? So we need the line of P and Q. How do we find that? Well, we know my P is the point, I forgot what it was, -3, -4. and q would be -8, 0. And we do know from pre-calculus or from algebra or whatever, high school math, we can actually find the equation of a line in 2 points. And if we look back at our tools from the previous video, we could actually look at this. We just need 2 points where we have x and y coordinates for both points. So let's use that tool, shall we? So we would have y equals m x minus x naught plus y naught, where my m is y minus y naught x over x minus x naught. So we just need to assign what's going to be x and y as well as what's going to be x naught and y naught. So let's assign that. So let's say this is x naught, y naught. This is x and y. Actually, we don't even need that. But let's just do it. So I guess, let's plug in. So y is 0, and then my m, x minus x naught, so that's x plus 3, plus y naught, so that's minus 4. And then we say my m is y minus y naught over x. Oops, -8 minus x naught plus 3. So that's 4 over -5 or -4 over 5. That's my m, right? So we get something that looks like this. Oh, but I forgot my x though. I think this was -8, I said. Wait, is this right? Now I'm questioning myself. I don't think I did it like this. Ah, I forgot how I did it. No, it wasn't like this. I just needed 2 points, and I needed to use one of them to be x naught, y naught. Yeah, but it could have been any of them. Let me redo it. Let's say this is x naught, y naught. This is x, this is y. So that would be something like this. We leave the x and y alone when we're doing this. I think I could do any of them. Y minus y naught. I could do that. Yeah. Okay, let's plug it in. So we know my y. I don't know my m, and x is a given. Y naught is plus 4. No, plus 3. And then minus 4. Yes. Now I just need to find my m. So my m is y, 0, minus y naught, which is plus 4, x again, -8, plus 3, that's -4 over 5. So my answer for the line is going to be like this. That's the line. So what I did was I just picked x naught, y naught, and x and y. Now I could do any, and it's still gonna be the same line. But then I just have to follow this formula. I have to leave x and y alone in the formula, these two. All I need is to find x naught, y naught, m, and I'm good to go. Okay. Let me know if that doesn't make any sense. So this is the line. Now, again, if we go back to the question, we're not done yet. We need the question. Is this line tangent to the circle? How do we know if a line is tangent to a circle? We have the circle equation, we have the line equation. How do we know it's tangent? Again, we need to find the radial line, right? And this radial line has to be perpendicular to this tangent line or this line of P and Q, which supposedly we think it's a tangent line, but we actually don't know that. So let's find out, right? So we need to find the radial line of this circle, and we're going to do a bit of geometry to do this. So to find the radial line, we need the negative reciprocal, we need the perpendicular line to this line. So the way I would do it is first we need to find the radial line. And the way we find it is we find perpendicular line to line P and Q, or the line that connects P and Q. I'm talking about this line. Now, the way I would do that is, so we do y, that's the same thing, and then the negative reciprocal of this. So that would be 5/4. And then again, I have my x naught plus y naught. I don't know what x naught and y naught is, so I'm gonna need a point from this circle. Okay. And it seems like I can do that? Question mark? Let me check. So this would be x naught, y naught. I think I can do that. Yeah, kind of like similar to what we did here earlier. We just need to find the 2 points. We need to find x naught, y naught. So, how do we do that? Again, we do that slope thingy that we did earlier, right? So we need the circle equation and something with slope. How do we do that? Well, it's gonna have to be question mark. Let me just check what I did here. Oh, but the thing is, I don't know the points here. Okay. Nah, they're really gonna make this difficult, huh? Mm. Oh, wait, it's asking, is the line through, I don't think we need to do this. The line through P and Q, it's actually talking about this. But here's, oh, wait. Ah, so now that we found this line of P and Q, the way we can figure out if it's tangent to the circle Mm, oh, we need to draw it. We need to draw that line. And then we find the radial line. Yeah. So we need to draw out this line of P and Q. So the way we're going to do that is, well, of course, I need to solve this first, make it into a form I can understand. Yes, 20 over 5. 22 over 5? Yeah. So I think I just need 2 points here. Does it intersect x squared plus y squared equals 5? I mean, it has to, right? Because we know the point P, -3, -4 does intersect. So we know that's 1. And P is also on this line. So we know that works. And -8, 0, which is Q. So we also know, oh, oops, it's somewhere here. 8, -8, 0, P and Q. So that's that line. Now we need to find a radial line which just goes from the center to oh, what? The radial line that goes from here to here. And this is supposed to be perpendicular. So this line right here is actually just y equals the negative reciprocal of -5 over 4, which is what? Oh, wait a minute. Wait. I'm missing something though. Draw the line to be. Oh, from the center of the circle to B. I need to find that line from the center, 0 to 0, to B, which is -3 minus 4. So that equation will then be, we can actually find the slope of this, which is just going to be 4 over 3 x. And that's the equation. Now it's asking, right, if the line P and Q are tangent to this circle. The fact is it's not. Line through P and Q. So I'm talking about this line right here is not tangent to circle. And the reason is since the slope of this tangent line, -4 over 5, is not negative reciprocal of the slope of radial line say M1, M2, being 4/3. They're not negative reciprocals of each other, hence they're not tangent. How did I know this? I looked at this fun fact that we discussed in, what was it? The previous video. Okay. So yeah, sorry if that took a while. That was a little tricky even for me as well. But if you do have any questions, please feel free to reach out. This is what I can do as of now. I hope you guys enjoyed and learned something. And really the key to this course or to solving problems like this in general is really understanding your tools, right? Of course, besides having the prerequisites, is understanding your tools and using these tools to solve these problems. Okay? Anyways, I hope you guys enjoyed, and I'll see you all in the next video. Thank you guys.